Awesome. I'll give a brief introduction. And then for full introduction, I think you probably have prepared. But Raj and I, we knew each other back when we were at CMU or just after graduation. Raj, like me, also graduated from robotics department in CMU, and we both have like passion towards like building hands-on robots. Right now, we are a little bit sad that we are not able to continue doing that. But I think Raj mentioned to me that he has a garage where he plays with robots all the time, or whenever he has free time. Now he's uh, probably has a lot of work from his company. And Raj right now is leading a division, and then the company is about automating risk adjustment in the insurance space. And they use one thing I was super excited when I spoke to Raj about is that they not just use the text space, but his work touches on multimodal space as well, uh, using images like how images of houses and determining how much is the damage. Like a lot of interesting applications that I haven't seen. Maybe newer companies are working on, but not a lot of big uh, players in the space are working on right now. Uh, yeah, Raj, yeah, you should get started on this. Yeah.
Sure. Thanks, Sai, for that wonderful introduction. Um, yeah, I work in the mortgage space, more in terms of helping people buy their properties once they decide which house to buy. Our company is in mortgage servicing space. So we help people buy properties and we help with documentation, appraisals, and things like that. So yeah, like Sai mentioned, we do NLP, computer vision, agents, a lot of workflow automation. Yeah, cool. Let me share my screen. Let me know if you're able to see my screen.
I'm able to say it. Yeah.
All right. Cool. So the topic that we decided to talk about today is uh, what goes on behind the curtains to take a cool agentic demo into production where it actually does some work. All right. So we'll touch upon a lot of principles. Again, like I said, we're not getting into too much of nitty-gritty details. So if you have specific questions, feel free to put them in the chat for Q&A. We'll handle them there, but mostly talk about principles, patterns, lessons learned from over 8 years of deploying models into production and building production-grade applications. All right. So that's my LinkedIn. If you want to connect, check out my profile, follow me, feel free to do that. So today's talk is all about practical lessons, no hype. We'll not be talking about what cool things agents can do. You all might be aware of it. There's a lot of publicity that's happening, demos that are happening. We'll get into how to get that into a working solution in production. So the agenda is going to be what do we see as a promise versus reality. There's a gap. That's what we will be addressing today. Core principles for production agents. There are 5 core principles that one needs to follow to make it into production. This is going beyond just a demo, a POC or a Jupyter Notebook, right? Key challenges and how to solve them. This is both for RAG and agents. Designing for scale, reliability, and ROI, which is what matters in an enterprise situation. I'm hoping that everyone here in the bootcamp is looking to get into industry, so that's why this is important for you, and I'll be talking about it. All right. So, and then we'll touch upon what's next in RAG plus agents. Where is this space going? Don't want to make too many predictions, but from whatever I've seen that's happening and issues that we're facing, how is that getting addressed and what to look out for? Again, we'll not get into too much details on specific tools because the tools get outdated in no time, but the principles stay, right? All right. So, how many of you have this experience where you see a really cool demo, big company does a demo keynote where the CEO of the company is showcasing some agentic capabilities or just AI capabilities, and then immediately it becomes available for you on your mobile device or on your laptop, and you go try it out, and everyone is like having so many issues in general, right? So it's a common thing that's happening. So the promise is whenever these marketing happens, uh, they're supposed to create a lot of buzz and talk about it. And they're mostly showing where it's going than to show what the reality is. So the reality is most of these demos are curated to perfection. They discuss exactly what prompts to put in. They've tested a scenario a bunch of times. So the demos work mostly. A few cases when the demos fail, but demos work great, but that's not reality. When it comes to production, there are a lot of inconsistencies, there are a lot of loads, there are a lot of things that you don't see in the demo that comes into effect. But the promise is agents are autonomous workers. They can do anything and everything, work on more complex things, take action for you. Same thing with RAG. It's a groundbreaking technology for retrieval to prevent hallucination. That's not always the 100% case, right? And there are many use cases for agents. So I'm excited for agents, but at the same time, we need to know where the pitfalls are. So not trying to say that this technology doesn't work. That's not what I'm trying to say here, but to say here are the pitfalls and how engineering discipline would get you to solve that, right? So it is the change of mindset to say it's not as easy as it's shown in the demos, but there is more work to do, and this is the work that needs to be done to take a proof of concept into production. And you would see, I think Gartner or another company was predicting that uh, about 75% of agentic solutions that companies are working on would not exist 2 years from now, or it would not continue to stay in production because it is complex, it is challenging. Not everyone can implement it the way we are looking at the challenges. So you are ahead of the game by attending this talk, and hopefully you'll get to take away some pointers to build agentic solutions that'll last for a really long time. All right. So, any questions so far? Is there like a chat that's open, Sai, or is it going to be a Q&A
Yeah,
separately?
I asked people to post the questions in Q&A box. We'll ask towards the end of the call.
Got it. All right. So, coming to the meat of the talk, right? So, core principles for production grade agents. First and the foremost thing is the task clarity. Think of agents to be like a new employee or junior employee, intern, like that, right? So they don't know the context. When they come join the company, they have no idea what you mean when you say deploy this, or when you say give me the ROI for this project. They have zero clarity or zero understanding of what it means. So treat any agents that you're building like that, like a junior employee who just joined the company. So you got to train, you got to review, you got to iterate, got to give it context as well. If you don't give the right context, it's not going to be right. So task clarity, there's a lot of iterations. This is where the prompt engineering comes into picture. So you would go and create tasks or provide either zero shot, which is to just give the prompt and ask it a question for it to serve you the answer. It could be extraction task, it could be summarization, it could be planning, any of these, or coming up new text or images, right? So task clarity is paramount important. One way to get this task clarity is to ask LLMs to clarify and ask you more questions so that you can clarify them. That's one way. The other way is for you to ask it to criticize your task and to make it more clear, so that you can start writing your prompts that way to make it very clear as to what is the input that you're providing and what is the expected output. If zero shot doesn't work, you do few shot where you actually give it examples. You'd say, hey, if I'm asking you for this, then this is what you need to give in this format. You shouldn't just leave it open-ended saying, hey, respond back in a JSON format. Obviously, your APIs are going to break. When you get a response back in JSON, where every time it's changing the names, it's changing the output format or the structure. So ask it very specifically to give you exactly what you're asking for. So that's the task clarity. This is all about prompt engineering. All right. Now, if you ask, let's go to the next one where we're talking about grounding with context. If you ask it for some specific question about your company or a task at hand, and it doesn't have that information in the context, which is meaning you either put it in system prompt or user prompt. If it's not present there, it's going to hallucinate. Like if you've asked who is the president of United States, it was giving you wrong answer because it was not having that information in its context, right? It's hallucinating. It'll probably pick it up from the previous years. It doesn't know what is today. It doesn't have a concept of what is today. There's no information like that provided to the LLMs by default. So that is the context building. So you got to build a context. If you're talking in terms of relative dates, you got to know what is today, and you need to pass that information to say, today is this date. And I'm asking you based on today's. Like, for example, if you're asking for news to be retrieved, you need to know which day's news you want, or you can just say today's news. But if you said yesterday's news, it's going to be tough. But if you convert these things into specific dates, times, it works great. So use tools with agents to do calculations, do the math, uh, get the dates, anything that you can do with a function that you can clearly define. That is great. And of course, retrieval augmented generation comes into picture here when the context is too large, then RAGs kind of come into picture to help build the context here. I know this is a lot of information. Again, I'm not getting into specific tools yet, but if you have questions, we can definitely discuss that. Put in your questions in the chat. All right, so coming to the third point, now that you have the task clarity, you have finished your prompts, prompt engineering is done, you have good data that's coming out. Then you do the context grounding, retrieving the right information, passing it to the context. And sometimes you'll have to verify the information that the LLM is providing you back is actually correct. You can do that with validation checks, functions that you can write to say, oh, I'm asking for a date. Is it actually a date format? I'm asking it for a JSON output in this structure. I'm actually getting that. And you won't get it 100% of the time. It will fail. It will be hallucinating, changing something. So you got to catch those things. There's also confidence that comes with the outputs, which are based off of log probs. You should leverage that to know how confident it is. Now that we know LLMs can make mistakes, now this is what we are engineering for. Instead of you assuming that LLM is always going to be right, you are assuming that LLM is going to fail, AI is going to fail. What do we do when it fails? And that's where we come into control loops. Control loops are nothing but when AI fails, what do we do? There could be rate limit. You can't keep asking for a lot of response from APIs. These are very process intensive systems. If you purchased a VM with GPU, then you have limited GPU. If you're paying by tokens, which a lot of them also supply, you have preset amount of tokens or quota assigned to you. And whenever you cross that, the API is going to fail. When you send a chat API call to LLM, it's going to respond back with an error saying timeout or quota exceeded error. In that case, how do you retry them? How do you go back and process it after some time? This could take Sai was telling me some of you are actually software developers, so you would have built a lot of APIs. Most of the APIs in software will be synchronous. You call the API, it responds back within milliseconds, ideally, maybe a second at the worst case. But with AI and LLMs, it takes several seconds, depending whether you turn on the thinking mode or not, or in agentic, it goes back and forth talking to multi-agents to come up with the answer. So your system could be waiting for response for a long time. So you got to account for those things and do the proper retries and handling of error. Uh, the other big aspect here is what happens when the confidence from LLM is low. You're asking for some information. What if that information that LLM extracted is not even present in your context? Or if it gave you a different format, what do you do then? Right? So you can retry, or you could pass it to a human. So human in the loop will definitely come into picture to be escalated and process this information by a human. Uh, Also, the feedback when the human looks at something that LLM is doing wrong, human provides a feedback, and how do you let the LLM or the agent in this case learn on its own from the feedback? So we're getting into a little more advanced topics here with like control loops. You can have as simple as you have the feedback, data scientist or you as a AI engineer looking at the feedback and changing the prompts, or you could let another agent modify the prompts for you and test it and deploy it. That's the more automated way, but I wouldn't suggest going there directly before you get to see some feedback. Another big thing for production is the observability. Log everything. When we do it with ChatGPT or one of these things for personal use, you would see that there are logs. But in production, we log even more. You just see the history in the chat, but in production, we need to log what was sent out, when was it sent out, what came back, and with what confidence, etc. All of that needs to be logged for traceability, for audit reasons, for you to know where the error is occurring and how to fix it, how to catch it and take care of it. So that's the observability. Simple. If you've been doing software development for enterprise, you know that's a key thing. Everything is logged. Every action usually is logged. Same thing with this. You let every interaction between agents be logged. So you know if the agents are making mistakes, because if you give it a complex task, now 5 agents got together to solve it. If you're logging only the input and the output, you would miss which agent actually caused the problem. So you won't have an opportunity to go fix it if you're just logging the input and output. But if you log every transaction or conversation between the agents, multi-agent system, you can debug and figure out where the problem is and go fix it. All right. So that was a lot of information. Just wanted to take a break to see if you have any questions. If not, we'll continue. Uh, but yeah, this is in simple terms, think of it like an intern or a junior employee who comes in without any understanding of what your company does, any context of business, and you gotta teach them. That's how you should read, and you should do several iterations here, and always have a human in the loop. We think our general population thinks AI is replacing humans, and with automation, uh, there are so many cases where AI fails and we need a human in loop. So always plan for a human in loop for escalation. So there's very small chances that AI can do everything on its own, but at least from what I've seen so far, even the best of the best models will need human in loop for high accuracy and be able to take a look at what AI is doing and audit. So the role of the human there is more of a auditor, more of a quality assurance person than to actually execute the task.
Awesome. We have some questions coming in the QA section.
Mhm.
The first one is, I can just read them. What is validation check and how is it done? I think it's referring to one or two slides back. You
Mhm.
mentioned about validation check.
Got it.
Uh, yeah, go on.
Yeah. So validation check is more like you asked. So in software development, we do this all the time. We send a request to API and we expect certain format for it to come back in. And as soon as it comes back, we do a validation check to say, did I get the right format? If the response is gibberish or it doesn't confine to the format you are expecting, you'd throw out an error saying, hey, here's the problem. I don't understand what this API is saying, and there's a communication issue. Same thing with LLMs. You asked LLMs to do something or an agent to do something, it comes back. You got to ground it. You got to know what you should be expecting. You shouldn't just leave it open. And if it's not giving you that, then you should raise an error and route it to human for review. An example would be you asked it to go and get you all the flights from Dallas to Ethiopia, let's say, and you're expecting this agent to give you back in certain format saying from to, and it matches the inputs that I gave. That's the validation check you're doing. And the price is in whatever currency. If it's in dollars, you should see it in dollars. If you get some text in place of currency, then that's a validation fail. So those kinds of things. And if the input destinations and output destinations don't match, then you have a problem again. So those are the flags that you would do. Um, if you're retrieving information from a document, then the validation check you would do is I asked, who does this property belong to? And it says Sai Prabhakar because he trained a bunch of data with a model, and he's like, uh, he had mock data with which he fine-tuned the model, and now the model always says it's Sai Prabhakar. So if he generate documents, it would have wrong name there without checking. So basically validation, what we are doing is when we call the LLM, we said, go get the data. And I also had some data with me to say, oh, this is, Rajshekar applied for a loan, and I should see that name in the output. If I don't see that name in the output, then there's something wrong. Right? So if there was hallucination and it puts name instead of mine, then it would catch it. So that's what I mean by validation checks.
Awesome.
Format, data, making sure the data is grounded to mean it's actually present uh, in the system wherever it's supposed to be.
Awesome. We have one other question before, or we can answer them towards the end. I think we are probably close to the time. Yeah, go on.
Mhm. All right. Some of the common challenges or pitfalls and how do we solve for some of these, right? Uh, common challenges you'd have heard of this if you built anything with LLMs or RAGs. Hallucination comes up very often. So far that a lot of companies in their chat assistants, they say this is AI generated content, it could be wrong. Please check for correctness. Um, so that's hallucination. LLMs typically are just pattern matching and predicting the next word. So they don't inherently understand, at least that's our understanding, that they don't still understand what the context is. And it's just finding past patterns and predicting the next word that should come next. So it's very common for these LLMs to hallucinate. You got to find a solution. One of them we just talked about, validation check. You could that's what I have it here as verification code. So you write code to verify if the data is actually present or it's in the right format, etc. You could also do multiple retrieval passes. If you're doing something like RAG, you could retrieve it multiple times. If you need this data to be even more correct from and protect yourself from hallucination, you have enough ROI, you could call multiple models. You could call OpenAI model and you can call Anthropic's Claude and see if both of them give you the same data. And if it's not fine-tuned, you should get different data if it's hallucinating. And it would it would give you the same data if it's not hallucinating, right? So different sources don't take the model from the same company. Most likely they use the same training data, and that's where the hallucinations could come from. Synthetic data and training data. The next challenge is slow response. We talked about this. It could take several minutes for you to get a response sometimes. If you try any reasoning LLMs, they're slow. They take 30 seconds, a minute, 2 minutes, depends on how much data you're giving it to. If the input tokens is too large, then the time to respond is also too large. And if you're expecting too much output from it, like if you needed to write a short story, it would take longer than giving you a yes or no answer. Right? So don't think these LLMs are in work in sync. So you should always plan for asynchronous processing. So you call and then you wait for it. It could take 30 seconds, it could take a minute, it could take 2 minutes, or if it failed because your quota is full, you got to wait for a minute and then make another call to get a response. So plan for asynchronous processing for dealing with the slow responses. Another technique is called caching, where it is it is also saving you money when you do caching. Caching simply means if the LLM saw certain input and it processed using by calling a third party LLM provider, you save the inputs and outputs. And if you found the same input again, you would just retrieve that information rather than making that LLM call to process that information again. Like if you kept asking, list all the countries in the world, it processed once. Now, if the same input goes in again, it can just retrieve it from a database search than to actually go and call the LLM and process and generate the output. So that's another solution that saves you money and also the time response time. Another big challenge is cost. You have to be very careful about cost. Always put limits. If you go to Reddit, you can read a lot of cases when people were trying out agents. If they had $50, $100, $1,000 limits, that would be, if it's prepaid, it would go to zero overnight. You let the agents play around and do something. It could get into loops. It could eat away all the tokens, consume all the tokens. So be very careful about the cost. It could very fast get very expensive. So how do we solve for this? Giving it the right context will definitely help. So instead of you asking or leaving it open, you ask it for very specific things so you can restrict its scope of work. That's one way. Using smaller models usually are cheaper and faster in response. That will also reduce the cost. But if you use the smaller models for complex problems and planning, it could cause you, you could get into loops. And also, you should put limits on how much money it could spend or how many tokens it could spend in solving a particular task. Usually there are token limits that you can set in any of the libraries that you use for agentic. It could be CrewAI, LangChain, Semantic Kernel, or any of the new tools that would be coming up. Uh, Most of them have these limits, so always enable them and keep tab on how, and don't leave the agents open. Don't give full access to databases. Don't give full access to go search the internet. Every API call is costing you. All right. Then for context matching, hybrid search is a good way to solve it. Just semantic search could retrieve a lot of things, but hybrid search kind of looks for specific words at the same time, also looks at the semantic meaning. There is more to context matching in retrieval process, such as having a continuous uh, context, having the context dynamic um, constantly getting updated from the internet or from the news or even IoT sensors, right? So those kinds of things are in the future that we would see. Those could handle the situation of poor context matching. Orchestration anytime you get into multiple agents, this will come up. And I would suggest keeping it simple to begin with. Um, try start with state machines. Then you can go and ask it to plan and execute itself. But do not ask it to, at least right now, do not ask it to go solve a problem without giving it some guidelines. It would burn up all your tokens. It would be very expensive. It could run off, get into loops, solve for something that you could you never thought of. So you got to put guardrails. You got to say this is all you can do. This is all the input that you get. This is all the output that I'm expecting. And anytime it deviates, you stop it. Anytime it exceeds the token count that you anticipated when you're developing, stop it. That's the only way you can prevent some of these from happening in production. When you're testing it on your machine, you're testing one, two orders, one, two tasks, or 10 tasks. It's not much you can ignore, but the cost kind of scale up as the number of tasks being processed. And usually in enterprise, you're planning for millions of tasks to be executed on a daily basis. So you have to be careful about these and keep tabs on how these systems are working. So that I would say every challenge here is fixable if you engineer for it from the start, and keep track, keep in mind about these things and plan for it when you are starting to build the enterprise solution. All right, so the next part is, now that we have something that we built, how do we design for scale, reliability, and ROI? A lot of us forget about ROI. People think about scale. Okay, if I'm able to run this one task, can I run 10 tasks or 100 tasks? How do I scale? More and more quota for processing, more and more GPUs, and more Dockers, right? Or pods for scaling. So that's one way. But if you want to scale within the task, then you need things like queues, prioritization, batch processing. Uh, Batch processing is used both for cost savings and also if it's not urgent, then you can definitely leverage batch processing. A lot of companies give you discounts on batch processing, so make use of that. Um, so for scaling, you'll have to use something like queuing systems because each of these tasks could be running for longer durations. Coming to reliability, um, you got to have redundant retrieval systems, and you got to anticipate and fail over when you don't get the right response. Um, you should also have in different regions, different backup LLM calls that you can make, different resources. That's how you could improve the reliability. Um, these are more similar to what software development practices are today, just applied to LLMs and agents. For ROI, I would suggest there are a lot of things to automate when you start looking at agents. Um, when I demoed agents internally, everyone was blown away, and they came with so many projects. Like, hey, can we do this? Can we do that? How soon can we do it? Because the promise is like that. When you see a demo, you think it's easy. You just write a line of code, a line of prompt, and it actually can do it. Um, but making it work for enterprises where the challenge lies. That's why we take months to go from a demo to something in production. So start with high value, low risk workflows. Don't take up anything that would cost your company a lot of money if you automated and it didn't work right in the first time. So build confidence, test with high value, low risk. Um, that one of the easy ways is to put a human in the loop, everything that's happening. Monitor how it's performing over a period of time. And then once you gain confidence, you could reduce the amount of work that's routed to human based on confidence, and then you can automate the remaining. Um, but focus on the high value tasks. There are a lot of them. You got to pick. Once companies get a taste of agentic workflows, they want more because it's fast to deploy. I'd say at least 5x faster than a traditional project to deploy. So cheaper, faster, and a lot of promise. And also the complexity, the level of complexity that agents can handle is far more than a simple LLM or traditional AI machine learning project could handle. The last but not least, measurement. Always have a dashboard or some metrics that you are monitoring to see how the system is performing in production. If you leave the agents unsupervised or without any monitoring, they could cause a lot of trouble. So have measurements. That's one way to show ROI, one way for you to know if the AI is doing what it's supposed to do and monitor, how long it's taking, how much it's costing, and make sure the costs are not skyrocketing beyond what you're expecting it to cost. And if you're scaling, I would suggest you focus on reliability and ROI first. Uh, then you can scale up. Don't build something that would immediately open up to millions of tasks in the first project. So I would say scale slowly, iterate, test, and move on. Right. So what do we have in the future? A lot of multi-agent collaboration is going to come up. Um, has anyone worked on multi-agent projects here? You could agents in themselves are quite powerful. Multi-agents make it even more powerful, but it also brings in a lot of challenges in terms of monitoring and understanding and fixing uh, any unintended behavior. So, and how it delegates the tasks, all of those things. If you haven't explored multi-agent collaboration, you should check it out. That's going to be big. Um, and also the tools for these multi-agents, MCP servers and things like that. Context-aware generation, there's a lot in the RAG that's still missing. You might think the RAG is pretty cool at this point because you just discovered RAG, but as you start using it, you would see the challenges that or the shortcomings of the RAG systems. So RAG needs to still evolve. There's a lot of context retrieval, context that's missing. Like I said in the past, in one of the previous slides, LLMs do not, or agents do not have an understanding of what today is or what a particular date is, or when you give a dollar amount, is that expensive or cheap? So you've got to bring all these context in, and also some of these agents might have to depend on live data, like uh, IoT data from sensors for weather, or there's a storm coming. If the generation is still picking up from the old, retrieval is happening from the old data, then you're out of date. You can't have agents that are using live data unless you're having data retrieved in a continuous fashion. Um, the other thing is tight coupling with business and workflows. Today, at least right now, a lot of agents and promise that's been made is one agent can do everything. I think there are some agents in Anthropic that are quite popular. OpenAI also came up with new agents recently. Uh, GitHub has some agents. So all of these are more like a Swiss Army knife, where it could do everything. It could do many things. That's kind of the promise. But what we will see going forward is we'll see a lot of specializations. Specialist agent doing something very, very narrow. That's where the future is going. And then you'd have a planning agent that communicates with different specialist agents to get the task done. So with that, I would say start small, build iteratively, measure ruthlessly, and keep human in review early on. Do not skip that step. So that's how I would put where that's what I see where the future is going without getting to the nitty-gritty details of the shortcomings and how it's being addressed today. But watch out for multi-agents, more powerful RAGs, and tight coupling with business workflows. Like there's an agent for booking airlines. There's another agent for booking uh, simpler, or let's say booking bus tickets or train tickets. There's another agent to just deal with the dates, booking, cancellation, workflow, orchestration agent. So each agent becomes more and more specialized, just like how organization is organized, right? We have CEOs, we have one layer below them, senior level folks, leadership. Then you have leads and managers. Then you have developers, senior developers, junior developers, QA. They're all specialized in things, and probably the most generic ones are as you go up in the organization ladder, they need to know many things, like a CEO or CTO. They need to know a lot of things so that they can bring these specialists together. And that's what you'll be doing as someone who builds a multi-agent system. All right, I think it's time for some questions. I have two slides to wrap up after this. So once we have the Q&A, we can come back to some of the takeaways and wrap the talk up.
Awesome. A good talk. A lot of insights there. I'll enable the chat for a brief while, but feel free to post in the chat as well as in the Q&A box. I also received some questions in my Discord DM as well. I'll ask those things. So before, let's give some people some time to type in the answer.
Sure.
Uh, so one question in the Q&A is, can we use AI agents in financial institutions where a little error will result in huge problems? So how can we use agents at that risk level?
So, like I said, grounding is very important. You validate every output that the agent provides. You shouldn't use it for calculations. Generally, LLMs are not very good for calculations. It needs to use tools to calculate. So if you already had a tool created for, let's say, calculating the ROI, um, you could ask the LLM agents to come up with inputs to that system, and it could call that code, which would then generate the output. And code is doing all the calculations, but the inputs are provided by the agents, and you ground the outputs of the agents to make sure they're relevant inputs. So if it's very critical, uh, there are other things that you can do, like anomaly detection. You could say, hey, I should be seeing the price range in 500 to 600 range. If it goes beyond that, catch it or escalate it to a human. That way, even if you're taking a loss, it's a smaller controlled loss. Um, Otherwise, use code where it can do. Don't use LLMs. There's a tendency to take the most powerful models, use them to solve every single problem out there. That's not the solution. When deep learning came in, everyone rushed to deep learning to even do forecasting and simpler problems. That shouldn't have been the solution. Now everyone's rushing to LLMs to say, "Hey, I'm gonna ask the LLM, it's gonna answer this to me." No, that's not always the solution. You should be getting to code. LLMs are good at writing code as well, so use LLMs to write the code, validate. If the process is not very dynamic, you should just write the code, review it, and use that code instead of leveraging agents for it. But if it's a
Awesome.
very dynamic system, then you need to use agents.
Awesome. Then another question in the chat. Do you think the next leap in RAG and AI agents will come more from architectural breakthroughs or from infrastructure and tooling maturity?
I would say both. Architecture is still evolving. There are different people, different architectures being tried out at this moment. Nobody knows, or nobody knows what exactly is the best architecture yet. So there is different trial and errors that are happening in terms of architecture, different proposals happening. So both on the tools, fundamental research, and architectures. Right? The fundamental research is going to take leaps and bounds in, let's say, RAGs or breakthroughs in LLMs, reasoning, how fast it can do, how less GPU can it use. Second thing is the right architectures. At some point, AI will, uh, when we get closer to AGI, it would improve itself. Um, there's AI that's writing papers and publishing PhD level. So uh, there are talks about it. I am yet to see a lot of innovation come that way. Today, AI plus human is able to innovate quite well. Just AI, not so much, but improvements in all architecture, tools, and fundamental research, all three are required to move forward.
Awesome. And another question from Paschal. What's the most effective real-time monitoring signal you have found for catching AI systems drifting out of spec
Mhm.
before the metrics visibly tank?
um, I'm blanking out on the metrics that we use. There's a metrics that um, we use to say, in simple terms, let me put it in simple. I don't know the exact name now, but in simple terms, if you see the LLM is consistently making errors for the five consecutive times, and you have your whole data is, let's say, 100,000 points so far. In 100,000, your error rate was low. Let's say it was 99% accuracy. Now, just 5 or 10 of these that came just now, because of a drift or change in format, some change in the world that LLM didn't anticipate, is now going to throw the system off. But if you're using traditional metrics like what is the average accuracy across the whole data set, you would not be able to catch it. If you do something like rolling average accuracy, and you're looking at the last half a day or one day or last 1 hour, just like how you monitor stocks, you could probably see this in action. And instead of then seeing a slow, gradual decline, you would see a sudden drop there. That's one other way to catch it. We use some signals to catch by saying, okay, what is the average variance? And if it goes beyond that consecutively for a couple of times, we flag it to say um, it's not.
Normally, kind of.
Yeah,
Awesome.
yeah. So something like that. It's borrowed from manufacturing world.
Okay, more questions are coming in. In developing an expense tracker using AI, what do you
Mhm.
think is the advice for rigidly looking out for achieving perfect performance? What model would you advise to use? And
Yeah.
that's like a more add-on to the question. I think this is about we have a hackathon towards the end of the call, towards the end
Okay.
of the boot camp. So maybe someone is thinking of their hackathon project.
Mhm.
Um, yeah, for finance tracker, budgeting, income and expense,
Mhm.
are there existing areas that they should be looking into?
So some of these, unless you're talking to an agent which is using tools internally, it is bad at math. If you ask it to add two numbers up, it'll make an error. So do not use it directly to do your math. Your math should become a tool. Your calculation should become a tool. The input to that calculation can come from your LLM or your agent. Classification can come from your LLM, which is very good at it, right? Semantic understanding. Let's say you have a shop name and in the credit card reports, you need to match that to either is it a restaurant, is it a grocery shopping, or something else? What kind of expense? Use LLMs for that. Do not use LLMs to do the calculations for you. So once it classifies, you can use regular code or SQL queries to come up with calculations for your final output. but do not trust agents which is not using tools with its math. A lot like if you ask ChatGPT or Gemini, it could respond back with a correct answer, but you have to test it, and you're relying on a black box at that point. They could be calling a tool. Sometimes it could skip calling that tool internally, um, and you would see a wrong answer. So I wouldn't trust them if it's especially financial data. Your code should write the equations, and the LLM should help you go from unstructured to a structured data.
Got it. And there are more questions coming in. One thing I would add to your answer, an extension of this question, is what model would you advise to use? I think based on Raj's answer, I would say some model that is good at picking right tools to use, right?
Yeah.
Claude 3.5 is a really good model for tool picking tasks, and you can start from there. But I would say uh,
Any reasoning
it
model is
probably
also highly
yeah
good. So Gemini, OpenAI's reasoning model. I think OpenAI came up with five just now, GPT-5,
yeah.
which has the intelligence to pick the right model on its own instead of we having to pick the model. So that's a slight improvement, I would say.
Yeah. I think another news like on the GPT-5 thread is it just came out and people are starting to hate it already. I don't know if the sentiment will change in Twitter space. It seems like it's not working as
Wow.
well as GPT-4
Yeah.
in certain things, or maybe we are just used to GPT-4 and this is a different behavior and things
Mm,
will adapt. But
mm.
let's see. We had similar response for Llama 4 as well, so I don't know. Cool.
Yeah.
And yeah, maybe uh, one last question. Based on your Q&A prompt, right? What is your biggest deployment challenge? I think I'll pose a reverse question to you, Raj, which might be helpful for people here. Like we are operating not everyone is operating in a completely new domain, right? And we
Mm.
are right now working on existing companies with existing culture, practice, and existing principles. What's the best way to uh, motivate or uh, uh, get like a stakeholder buy-in for let's say you want to start to automate something. I think since
Mm.
you have worked in the leadership capacity for a while, you probably have some interesting insight that's not like an obvious answer.
Yeah. Very good question. I would say start small, show them lift in high ROI, high impact tasks, but with low risk. Pick those, show them the impact. Make sure you do your homework and engineer the right solution. Otherwise, that first project could either kill you or make you a rock star. So if you propose something, make sure you take care of these engineering practices, uh, and it works in enterprise. If you just go with a solution that didn't work, it would be so much harder for you to go back and convince them again. Um, I think the question is not anymore about AI or not. It's more about, do you have the capability or does your team have the capability to solve this, or should we get help from outside? I'd say that's what business leaders are thinking. Should I go third party? Should I go to our team? Or if it's third party, the startup or an established business.
Awesome. Uh, okay, one more question came in. Uh, Last question, I promise. So
Mhm.
this is an interesting question. Most RAG systems fail silently by retrieving plausible but incomplete context.
Mhm.
I think this is an example of a failure, right? That is silently failing. How do you detect and measure those silent failures before they reach end users?
I think that this is very context specific.
Yeah,
You need to understand what kind of data it is. If we can detect using simple um, logic in the validation, you should do that. Um, if you are Another thing is you can use multiple systems. Like you have two RAG systems with two different encoders or vectorizers in place and two different retrieval systems, and see if both the retrieval systems give you the same output. If they give you different, or you can also concatenate them to say, I'll take all the retrieval that came from RAG 1, RAG 2, make a supersetter of that, and pass it as a context to the LLM. That's a doable thing. Uh, Another thing is if the context is too large, try to break that up into multiple tasks. Let's say you have a 1,000-page book that you need to refer to get a response. RAG might, again, RAG will go fetch some data, and you only pick top five. What if the answer is in the top like 20 or top 100? Uh, Again, when you pick so much, that might not be enough context window for LLMs to understand all that context. So uh, two approaches to this. One, break down the pages, make multiple calls, tackle, let's say, 50 pages, 100 pages at once, and then uh, try to summarize and go back with it. The other option is you summarize and you start digging deeper. So you start peeling one layer at a time. You summarize a chapter. Now you have that in your RAG. You go to that, and then your context becomes that whole chapter. In that, then you search again within that context. So it's like you start peeling layers and getting to your answer one at a time. So if I open up a book, I first pick which book should I open. If I'm at a library, I can't open everything and look at everything, right? Pick the section, pick the book, pick the chapter, then you go to the chapter and scan for your answer that you need. And if that's not giving you the answer, that's where the business logic comes into picture. If it's not able to answer, you should be smart enough for the strike system or this agentic system to go open up another book and do the same and get the information from there. Or go search internet and get the answers and go pick up the book again, which is like a recommendation from the internet or something. So these systems are, you're right. The RAG fails there right now, but these are the future for RAG. This kind of retrieval systems, and agentic makes it possible. So both are going hand in hand and making it smarter and smarter.
Awesome. I think we are like 15 minutes over the time. Thanks for being patient and answering all the questions, Raj.
All right.
Uh, awesome. If any, do you have any announcements, comments? Yeah.
No, I have two
I
more
just want to say
slides. Let
thank.
me. Oh,
Oh, yeah, yeah. Sorry.
Uh,
My bad. I thought you finished.
okay,
Okay.
all
okay.
right. So I think someone asked about the implementation. So I had
Yeah,
so
yeah.
now we had all the question answering. So I just wanted to give how do you go about like implementation roadmap. Uh, you do the assessment, prototype, production, scaling. Very simple stuff. Again, if you want to take a screenshot, this is your time to take a screenshot of this. Um, and one last thing is the key takeaways. Always focus on engineering more than prompting. It's the other way around when you're experimenting and doing demos. That's why I wanted to stress more on focus on engineering. Production success depends on engineering practices than just simple prompting or even complex prompting. Uh, Quality retrieval is critical. Sometimes they beat um, larger models uh, as soon as you have the right context. So focus on RAG capabilities and the right way to retrieve the required information and provide the right context to the LLMs. Start small and scale smart. Right? Start with the high value, low risk workflows. And yeah, humans are essential. Do not think of replacing humans completely. You'll need humans to review and catch the errors, especially if you're working in a restricted environment or financial environment where the stakes are high. All right.
Awesome.
So yeah.
There was a request to go back and slide so people can take a screenshot.
Oh, got it.
I think someone is drawing on the screen. Let me try to, and yeah, that's fine. We're almost at the end of the talk. Uh, yes. Uh, Cool. Thanks for the talk. And Ifani, do you have any final words, announcements?
Yeah, Raj, thank you so much. I learned so much. I didn't know what to say. This was such a fantastic talk. I'm sure everyone on the call enjoyed it. We'd definitely love to have you again sometime in the future. Um, and yeah, so happy for this session. Little announcement to everyone, please. Our class will be next Monday, not Tuesday. So we're going to send out an email just to remind people. The talk on Tuesday had to be shifted to Monday because the speaker was not going to be available on Tuesday. So that's just a little thing to note. Aside that, I think that's everything from me. Thank you once again to everyone who has joined the call. Raj, thank you once again for your presentation. I'm definitely going to watch it again on YouTube. So probably going to be posted on YouTube very, very soon. And yeah, that's all from me. So thank you from all of us at NSK.ai, and we'd love to have you again sometime soon.
Thank you for having me. And I
Awesome.
hope this talk was useful for you guys. All the best.
Awesome. That was great. Talk to you guys in the next part.